Hello, welcome, and a very nice evening indeed. And today we have another sound card of sorts, the ReSeed project. Let me explain a little bit. You can see the edge connector here, which looks not like the normal sound cards that we had on this channel, mainly for the IBM PC incompatibles. This one here is for the Commodore C16 plus 4, the whole 264, 246 line of computers, because they did not have very good sound at all. They were utilizing that TED chip, which had lots of colors but no sprites, and also only, I think, 2 square wave channels or something, which sounded pretty weak compared to the relatively rich sound of the MOS SID chip, the 6581 or the 8580, which was a rather complicated and complex 3-voice synthesizer. And I do have 2 of those here. Let me focus down a little bit, see that there's not too much glare. Here is a 6581 from 1985. And there's a 6581R4 from 87. They both should be working fine actually. So perhaps we're gonna use them in this project, because this is basically a SID sound card for the Commodore 16 and the plus 4. Basically, this is the footprint where the SID chip will be placed. You can use either the 6581 like this, or the 8580, which is produced in a different process, has a slightly different sound, and also, most importantly, takes different voltages. So there are 2 different ways that you can build this thing. There are built instructions in the project, which is also why I have 2, because I want to build both variants actually. However, not sure if I will get the 8580 to work, because I don't have a spare one at the moment. I could remove the one from the C64C, but I also have this one here, the ARM SID. I have 2 of those. One is already in one of my C64s, and the other one is here on this IBM PC renovation sound card reproduction. And this can actually emulate either of the chips, but it's not quite clear if it will work on this card, because the SID chip is clocked higher than usual. Usually it's clocked at around a megahertz or something in the C64, same as the clock of the CPU, but the C16's clock speed is higher, and the original SIDs will work as far as I know. But, for example, the Swin SID won't work, because it will definitely do wrong things. So the ARM SID might or might not work. Don't know if anyone ever tried it, but we will try it. So yeah, let's see. But I will definitely build the 6581 version first, because if the ARM SID doesn't work, I can use one of my original SID chips. The power supply for this will be this nice little module. It's an MT3608 clone board basically, and not quite sure where the out is. It will go something like this, and replace a bunch of components and make it much easier. You can then tweak the stuff here, the potentiometer, to produce the correct voltages using the multimeter or the oscilloscope to probe. Yeah, there's a very nice interactive BOM. There are very good assembly instructions, so I will follow that. I've got a bunch of components over here. So we'll populate this as far as we can until we need to calibrate the voltage here. And then I'll probably first try this with the ARM SID, because I can buy simply another ARM SID, but killing one of my 6581s would be a bit more sad, actually. And of course I can also probe on the socket if the voltages are correct and stuff like that. Yeah, but I think I've talked enough. Let's get started. Except one note. What software is actually supporting this? Because all the software for the C16 is using the TED chip, obviously. But there are a handful of, at least a couple of demos that I know of, that use this card, and there might be some games. We'll have to figure it out. Maybe Lykia supports that, not quite sure, but there are definitely a handful of demos that don't have any sound if you don't have this card. So there's at least two things that I can show you that I know of, and maybe Lykia or some other game also supports that. So yeah, but now I've talked definitely enough. Let's get cracking. So we already progressed pretty nicely. I had one little problem actually. I soldered the 180K resistor, which is not needed for the 6581 variant. This whole project is not super hard to solder, but the bill of materials is a bit tricky because depending on which chip you want to put on there, and you can only put either the 6581 or the 8580 on there, the components change a little bit. Some have to be left out, some have to change in value, so you have to be very careful. Also, this is the socket for the SID chip, and I could have used the precision machined socket, but for these old chips I think I'm gonna stick with something like this, although maybe not. You have to cut out this part because the 245 driver will be put in like this, and I'm gonna shut off my soldering iron very quickly. Let's have a look what the pins on the arm set look like, because if they are machined pins, I think I'm gonna take machined pins as well. Yes, the arm set uses machined pins, which should be fine. I mean, I use dual wipe sockets here on this card as well, and they are pretty thin and they're gold plated and very nice. Yeah, maybe I'll stick with that. I'm not super sure. I think for the round pins, round sockets would be nicer. Let's see if I can find one and if we can cut it in the same way. Yeah, so indeed I found one of the machined sockets, and I think this is way nicer for, especially for the arm set. Yeah, I think this should be just fine. So yeah, let's continue. There's a few more things to do, and especially we'll have to calibrate the power supply in a minute, but let's populate the rest of the components. So I think we got it. The voltage regulator module is in place, which saves us a ton of other components that you can see here. So that's good in a way. These components are all not necessary. C20 is, I think, also not necessary for the 6581. But other than that, everything's in here. The next step is to calibrate the voltage. We need to probe on these two holes here while this thing is plugged in, powered on, without the SID chip. And we have to turn the pot screw here until we read 12 volts, which is the voltage that we need for the 6581. I think the arm SID just ignores that, it just runs off the 5 volt. But I do want to try a real SID, and the arm SID might not even work. So let's pick a C16 and plug it in, I would say, and yeah, tune this. Oh, I actually forgot one more thing. That is the ferrite beads down here. I'm taking one of these things off, which is these. They are pretty tall, and they might touch the metal shield of the C16's cartridge port, because the cartridge will go like this. So it's recommended to put something over them. I'll use this heat shrink thingamajig, and yeah, let's blow some hot air on that and shrink that so that it's actually insulated. Otherwise you get a short on the power rail, which is bad, obviously. So here we are. It's a bit precarious with my setup here. Everything is plugged in, the C16 is running. I'm not capturing at the moment, but the black probe ground needs to go into the middle pin here, and the other probe into the upper one. And we see it's 4.87 volts. Now we need to turn that knob over there to get this up to 12 volts. And let's try this. Very quickly, I think the old module was defective. It always output 4.8 volts, no matter what I do. But look at this. Let's probe here. We have 12 volts on the spot, which is exactly what we need for the 6581. So that's perfect. We can plug in the SID chip and test drive this thing. I also put some conformal coating on here. We'll also put a little bit on here so that the pot doesn't detune, basically. The conformal coating will help to not have the short circuits that we have here. Yeah, but you can also use like insulation tape or something similar. So these are two boards assembled. These are the two variants. This one is the 8580 board. I put a sticker on the back because there's no space on the front, but there's space enough on the front of this one, which is the 6581 variant. I do not have a spare 8580, which is why I'm using the arm SID in here. I also tested the arm SID over here, but then used an original 6581 R4 in here from 1987. Both are pretty functionally similar. Both have the joystick port, the audio in and audio out ports, but actually the cartridge also feeds the audio signal into the audio in via the cartridge port, and that goes then off to the TV if possible, except if you have a cheap cable like I do, which is this one here, where the audio in pin on the connector here is grounded, which also grounds the audio signal coming from here. So I'm using just a basic 3.5mm to 2" cable from the audio out socket. That's just so that you know that this is an issue. So either I'm gonna fix this thing and just remove the solder blob from the connection here to the ground pin. Anyway, as you can see, there are slight differences here and there. First of all, there's a volume pot, which I turned basically to maximum on both, because it's more The author says it's more of an attenuation pot if you need to turn down the volume, but you can basically just crank it to the maximum or to roughly the maximum, and that'll be fine. Then there is a pot here for the 8580 for the Digifix. The problem being that the 6581 had a hacked capability basically to play samples, voice, whatever, and that would not work on the 8580. It would be too quiet basically. And there's a jumper here which I left open because I'm not using an 8580 but an ARM SID emulating an 8580, and the ARM SID has basically the Digifix already inside of it, so I don't actually need this whole thing, but it's there. If I were to put an 8580 in there, I could put the jumper on the bottom part here and tune the strength, I guess, of this fix. Never tried it though, because there's also new sample playback routines, especially for the 8580. Alright, then both the DC-DC modules were calibrated to 12 volts and 9 volts respectively. The ARM SID doesn't care about either of that, but for the original chips you need to make sure that this one gets 12 volts and the 8580 gets 9 volts, because the 8580 will be fried if it's too high, and here the DC modules were at 25 volts or something, which would fry either of the chips, so be careful with that. Plus I put some conformal coating, which you usually use to cover up broken spots on the PCB, with UV light hardened on there, as well as on the ferrite beads, which look weird now. I put some conformal coating on there as well, and put a heat shrink tube on there and shrank it using my heat gun. Same here, because there is a metal shielding on the +4 and the C16, and these things can short out on that, and that's a problem, obviously. You can even remove those. The author says they are for more noise suppression, but you probably can't hear it, so they are optional components. I will leave them in for now. I've checked if we could build a case for that, but the PCB is, I think, 1 millimeter too wide or so to make for a good, well, size. I can show you the cartridge port here. This is the cartridge port, and when I put in one of these things, there is hardly any space left here, so I can't really fit a cartridge shell across that. And here you can see how close the space is for the ferrite beads. So I think I will leave these PCBs blank as they are, which is a little bit of a shame, but I guess since this is relatively early design, this is iteration 2, we might see perhaps more iterations of that. Still, they are immensely useful, and maybe you could build something that, I don't know, does some clever tricks on the top part of this thing, but also there are no mounting holes for a screw hole in the middle like you would have on normal ROM cartridges where you could attach the PCB to. So you definitely need the space down here to support the case, but it's just not there. So they will stay blank and naked, and that's okay. We will also test run a bunch of demos, 2 demos and Lykia the game, because I checked those all support the SID chip. And there's also a bunch of other software which I will quickly put on the screen here that supports this card or similar cards with the SID chip. However, I won't test all of them, and many of them are pretty old. They are like disk mags and intros and stuff like that. Yeah, you can check them out by yourself. There's a link in the video description. I hope I didn't forget that. Yeah, but that's more or less it. Basically, the volume attenuation Also, I had to make sure, I forgot that at first, there's a bunch of jumpers on the backside. When we're using this power supply here, you need to put jumper 3 here, just a blob, because there's usually a linear voltage regulator here, which has to be bridged. Also, I think jumper 2 needs to be on the top and middle pad where it says reset. And I think that's it. I'm not sure what JP1 is for. Yeah. And there's many different options how to build this, but I think the option with this DC-DC board is definitely the most simple and cheapest one, because those are like €2 a piece or something. And that's pretty neat. All right, we will have a listen and we will compare the ARM SID versus the 6581. I do like the ARM SID. It has a very nice SID emulation. However, I think you can still hear a lot of differences when hearing the 6581. I think the treble, the high sounds are a bit better actually on this one than on the ARM SID. But I think the ARM SID you can configure in its frequency response and filters and stuff. So yeah, it's definitely different. I can't say one is better than the other, but you can build both basically, and they make a very nice addition to the +4 C16 264 range of computers. And yeah, I hope there will be more demos and games that at least optionally support this. It's a bit sad if people miss out on all of the sound if only this card is supported. But Lykia, for example, has dedicated versions for the TED chip and the SID chip, and in parts even uses both. For example, the speech samples in Lykia are all from the TED, even when you have the SID chip in there. But the music, there's different versions basically of the game. I think due to size constraints, you couldn't get everything on one disc as it is. Yeah, so let's fire up the games and demos and have a listen.
Warning, there will be flashing images ahead, so if you're sensitive to that, you might want to skip this part. But other than that, here is Lykia with the original TED sound. The TED only has square waves, so it will sound much harsher and not as good in some opinions as the SID chip. So let's listen in. There will be also some voice samples.
Made for you.
So that was the original TED soundtrack, but there's of course a dedicated SID version of Lykia, which supports the ReSeed and compatible boards. So let's have a listen there, and first of all we will try out the ARM SID, which works perfectly fine in the ReSeed. And now as a comparison, this is the 6581R4. I think the treble, the high notes are a bit more clear, but judge for yourself. Definitely is a very viable option if you don't want to use the ARM SID.
Made for you.
Next up is the Shade demo, which is an interesting demo from like 15 years back or something. And it only supports the SID chip. A little bit of techno. Again, here's the ARM SID first. And of course the 6581R4 for the comparison. The next demo is called False Idols and is a production from this year, so super recent. There are still productions made for the SID chip on the Plus 4. Let's have a listen on the ARM SID first. And of course, as a comparison, here is the 6581R4.
So that's it for the ReSeed SID cartridge for the C16, the +4. And in theory, all the 264 machines, although the C116 doesn't have a cartridge port, I think, or does it? I don't know. I can only test on the C16 and the +4. The amazing thing is that the ARM SID works and the board, which is not a given. There are other SID clones that don't work or don't work correctly. So this is a very nice thing. And it works both, of course, in the 8580 and the 6581 variant. But you can, of course, also use either of the original SID chips. The cost is not super expensive if you make one of your own boards. I don't think you can buy it anywhere. The link to the GitHub repo is in the video description. So that's that. Yeah, you need a bunch of components. You definitely need some kind of ARM SID or similar. The rest is basically doable by ordering from Mouser or DigiKey, etc. The power supply modules here, you can get them off of eBay or AliExpress or something like that, and they are rather cheap. A future version, what would I want to see in a future version? Definitely slightly narrower, a little bit narrower PCB, so that you can put on a cartridge shell, basically 3D printed or something. It would be nice to have all SMD components so that the height of the whole thing goes down, with the exception, of course, of the DB9 port. Maybe make this optional, because perhaps you don't need that. You probably already have DB9 adapter for your C16 or +4. Also, I would suggest taking an ARM SID and soldering directly to the PCB. The SID is probably a bit too valuable to be soldered directly. Yeah, but if you could do that, then you would have a very low profile cartridge that could even be put in a shell. But as it stands, it is a very nice prototype that works perfectly and with a very high audio quality, I must say. You heard that yourself in the previous demos. But that's it for today. I would love to hear some comments. Also make sure to share, like and subscribe. The usual stuff, especially the sharing on social media, is very important. And I love to hear back from you, so put some comments down there. And if you want to support me, because these things don't come for free, you can do so via Patreon, Ko-Fi, or PayPal, or even the YouTube premium membership stuff, things like that. This is always greatly appreciated and helps me to pay for these little things. And yeah, you will see the results in one of the upcoming videos, obviously. Anyway, that's it for today. I hope you enjoyed it. See you next time. Bye.